Now you know we're recording. All right, so let's take a look at another one of these problems and stay with the same strategy we've been talking about, which is everything we've been doing up till now. The only difference is that we're adding the additional step of asking, before I try to factor it, is there a greatest common factor to all three of those terms that are in it? 2? Okay. What's nice about this? I'm going to use 2 for now. We can go back and talk about other numbers in a second. If I factor a 2 out of all three of these terms, so 2 goes into 12, leaves 6. 2 goes into 48, leaves 24. 2 goes into 48, leaves 24 again. You can still look to say, hey, is there still another common factor in each of those three terms that I can pull out?
More 2.
Is there a number that divides into 6, 24, and 24? 6 does. Okay, so let's pull that 6 out. So b to the third, because 6 divided by 6. 24 divided by 6 leaves 4. And 20...
Started with 6.
If you had started with 6...
Wait, how did you get 6?
I was just asking, is there a common number that divides evenly into 6, 24, and 24? 6 does. So let's pull it out. Now, if you can right off the bat look and go, oh, hey, 12 divides into all three of those, you could do that. Here's the other catch, though.
Where did you get the 6 to start?
I just thought of a number that went divided into it. So I said, let's try, oh, wait, this 6 here?
Yeah, the first 6.
This 6?
Yeah.
12 divided by 2 leaves 6.
Oh, and then 2 divided by 48.
Right. Because remember, when we did, yeah. We're going to get to that, yeah. And we'll talk about B.
Why is there 2 on the outside?
Okay, guys, shh. Remember last chapter when we talked about distributing, where if the number was on the outside of the parentheses, you'd multiply all three of the guys inside it by that value? Distribute it. Factoring is the opposite. So by saying that 2 divides evenly into 12, 48, and 48, I can factor out of those 3. In the last example, I wrote this step down as part of it. I wrote out 2 times 6 would be b to the third, plus, you're right. Yeah, well, this is the exact same guy, right?
So if you factor it out, you get the first answer.
Right. When you factor out a number, you make it easier to work with. And that number 2 on the outside is a result of saying, hey, there's a common 2 in each of these terms. Now, if you can go straight to the GCF, the greatest common factor to all three of them, you save yourself a little bit of work. But if you don't spot that right off the bat, like we did in the last example, right off the bat, well, the greatest common factor was 2. So we were done once we pulled it out. This one's a little harder because it's like, well, there might be some others. Now, Lacey also pointed out, hey, there's a b in all three of those terms, right? So let's pull that number out. So now on the outside, I've got 2 times 6 times b. B to the third divided by b leaves b squared. 4b squared divided by b leaves 4b. And 4b divided by b leaves b. If I distribute 2, 6, and b over that trinomial, I'll be right back where I started. The greatest common factor of those three terms was 12b.
I don't get this at all.
How did you get 4?
All right, wait, slow down, calm down. One question at a time. Oh, wait. I made an oops. Let me fix it. That's a...
Are you recording?
That's a 4. So that's a 4. There we go. Now, who did I lose?
Me.
What happened? All right. Where did I lose people? Let's find you.
How did you get that 4 to start with?
One at a time. Which 4? There's a lot of 4s up
In
there.
the second.
This 4 right here?
Yeah, all the 4.
That 4. This 4.
Yeah, that one.
Okay. 24 divided by 6 leaves 4.
I thought you
Remember, I'm not distributing. I'm factoring. I'm doing the opposite of distributing. I'm pulling out the numbers that they have in common.
How did you get B3?
Because this was 6b to the third.
Yeah.
So if I pull off a 6, that just leaves b to the third.
What is your right there?
Because the goal is to pull out the common factors, to make it simpler by saying, hey, this number multiplies in all three of them, so I'm going to pull it out. Because remember, it's the opposite of distributing. We haven't even gotten to the guess and check part yet. All we've done so far is say, what are the common factors in each of these terms? Let's pull them out.
Are we gonna guess or check?
Yes. From here, yeah. But we haven't gotten to that part yet. So I still want to be sure we're all clear with this step, which is supposed to make the problem easier.
So you did 40 divided by those, which is 1.
Yeah. Or 24 divided by 6, actually. This 24 comes from 48 divided by 2 leaves 24. 24 divided by 6 leaves 4. B squared divided by B just leaves B. The greatest common factor of 12b to the third, 48b squared, and 48b. Between those three terms, the GCF is 12b. So I can pull that out of all three of those terms, and that leaves me b squared plus 4b plus 4.
Why don't you just do that in the beginning?
If you can spot the GCF right off the bat, do that. Pull it out. But if you don't, like if you're like, GCF stuff never quite clicked, I'm not good, I don't like doing the work, you can just take it step by step. Keep going back to the trinomial and asking, is there any number that divides evenly into all three of these terms?
But won't that be like very time consuming?
It'll be less time consuming than trying to guess and check your way through factoring something like 12b to the third, 48b squared, and 48b. That's the catch. You can still do it by hand. You can still guess and check. Trust me, it's exponentially more time consuming to do the bigger stuff.
I just don't get why you don't just start after you did when you drew the line.
See?
Because if you start off trying to factor 12b to the third, you have to deal with, let's see, 3b squared times 4b, 2b squared times 6b, 12b to the third times 1. And there's so many ways, so many combinations, you'll be here a long time. If you pull these common factors out first, you save yourself a lot of work. And the whole point is to make it easier.
What's the answer?
Oh, we're not done yet. We still have to factor b squared plus 4b plus 4. Now, the good news is because we pulled the GCF out, there's not a lot of work left to do. I mean, what multiplies together to give me b squared? B and B. And then 4, well, that's either 4 and 1 or 2 and 2. Now, to get to the point that was raised when class started,
That's 2 and 3.
if that leading coefficient is a 1, that's right here, right? Then I'm looking for numbers that multiply together to 4 and add to 4, which are 2 and 2.
Dude, what are those lines?
Would it be flat? Oh, yeah.
Those are my lists of possible factors. So if I test out b plus 2 and b plus 2, well, let's see, that's 2b. Those are 2b. They add up to 4b. That's what I wanted. So my final completely factored answer is 12b times b plus 2 times b plus 2, or 12b b plus 2 squared.